Okay, it appears as something that may interest you Americans, seeing it's summer over there. There have been some sneaky little laboratories. We've got CSIRO over here who's worked this out, and also NREL in the United States. CSIRO is a government-run thing here. And basically they've worked out the next generation of evaporative cooling systems. And the one the CSIRO's got is basically what they call a desiccant wheel. Now, desiccant is that crap you basically get with your dehydrated foods. So you might be like me and buy dehydrated mushrooms from one of these Chinese shops, and they've got a little desiccant pack in there. And if you ever buy any of that nori seaweed snacks or whatever, or the ones for, you know, making California rolls, sushi, whatever, you'll notice they've got little desiccant packs. You guys know what desiccant packs are anyway, but they've basically got a wheel with, like, it sort of runs through two compartments. So just imagine you've got a wheel like that, and then where your drive shaft for your wheel is, you've got a wall and seal sort of thing. And basically what happens is this wheel has desiccant held in there with, I don't know, sort of like a coffee filter staff, or most likely probably just like a mosquito mesh or something like that. And this wheel slowly moves around on a tiny little motor, like an electric toothbrush motor or something like that. And basically what happens is it takes the moisture out of the air as it's coming into this evaporative cooling system, and then runs through a normal evaporative cooler. And what this basically means they can do is they can use evaporative coolers in moist areas. And then on the other side of the wall, you basically are using, you know, the heat of the sun or whatever, or some sort of, you know, solar collector, sort of a thing that uses passive solar heat to dry out the desiccant. But NREL in America has done one that's a bit different, and they actually use a liquid desiccant. And I didn't quite get the way their system works, but yeah, basically it's similar to the CSIRO one. I don't know if they sort of can get air to cool, if it's just a point of trying to keep the humidity out of the air before they cool it, so you can use it in humid places and stuff like that, and still actually have evaporative cooling be able to be used in humid places. Or they're trying some sort of a stunt whereby, and this is one, I don't know if I've misunderstood it, or this is one I've thought up myself or what, where basically they cool the air evaporatively and run it through desiccant, and basically when they run it through desiccant, it removes the moisture, it removes the humidity, but it doesn't make it any warmer, it stays cool. So as your evaporative cooling, as you know, cools the air, it's basically cool but not humid. And then they may very well stick it through another evaporative cooler. You know, so you basically, instead of getting one temperature drop, you can get two temperature drops, or do it again and get three, you know, and then basically have air that's really cold coming in through this system. And of course, you've got to have a decent sized, you know, inlet and that, and, you know, you may have to sort of have it go through a lot of desiccant to be able to dry it, compared to the size of the fan that is ultimately sucking the air through, so it only moves through the desiccant rather slowly. You know, with, you know, small air inlet, but then a giant, you know, amount of desiccant, so that the incoming air only goes very slow, and, you know, because of the large inlet and the large amount of desiccant, so that it actually gets a chance to get dried properly, as opposed to just suck it straight through and still humid. But yeah, it's interesting to see that there's sort of, you know, basically this system is able to use an evaporative cooler in humid climates, and they may be fiddling around trying to advance it even more. There are ones you may see, I think it's the Colorado, and that's to me it looks like what I've seen called a two-stage system, but instead of being like an outside air constantly drawn in and then you've got to leave a window open to get the you know, allow the air to go back out so you don't overload the fan. This is like a recirculatory system with ducts in the roof and then more ducts like, you know, on the floor sort of thing. And basically the pipe that this air goes through gets sucked up near the ceiling. It gets spat out to basically an evaporative cooler that's cooling the pipe. And it sort of looks like a radiator dipped in water basically, and comes back through to the ducts in the floor. But that sort of, they're going on like that's great, but it basically, as far as I know, it's called two-stage evaporative cooling anyway. It's nothing out of the box. It's been around for a fair while, but that will allow your indoor air to get close to the same amount it would with evaporative cooling, but not have an increase in humidity, because things such as antique pianos, you know, very special wooden tables and whatnot, you know, certain things sort of get affected and stuffed up by the humidity, and some pianos have been known to go out of tune and stuff like that by the humidity caused by evaporative coolers that wasn't there before they got said evaporative cooler. But anyway, I'll chuck the links in the description, because it's sort of the one from the CSIRO and the NRL, because it's, if you can dig into it a bit more, you might understand it a bit better than I have, because I've only seen it like, you know, once or twice. And yeah, it seems as though we may be on the verge of a new type of evaporative cooling, and very efficient, and you know, without the same surge you have with compressor systems. For those of you who don't know, because of the way inverters are set up, they're not terribly good with water pumps, I've found personally, and also I had a 75 watt water pump. There's a transfer pump for a pool, but it's got a head of like, I don't know, 2 meters or something like that. Didn't want to run it. Why? Because it's a motor that's starting under load as it starts, and same as your fridge. The second that thing starts, it's starting under load. Same as your air compressor, same as your freezer, same as your, what's his name, air conditioner. Now they can run, just you need one that's rated well above what the rating, the wattage rating is for the air conditioner. So if you've got a compressor air conditioner that's 500 watts, you're going to be looking at needing at least, so you know, it's probably like a 6,000 watt inverter from what I've heard, because you might get through it all right, or one that's got a 6,000 watt surge or something like that, because I've been told that when they initially start up, because it's an engine that's starting, but it's starting with a load already on it, you know, it can be a real pain in the arse for the inverter. And, you know, that's one of the reasons I've got a 12 volt fridge as opposed to a mains fridge, because it runs directly from DC. There's no inverter involved in it all. But, you know, with evaporative coolers, you don't get all that, obviously, because when it first starts, the fan isn't actually pushing much air as it initially starts, because it's only going so slow it doesn't build resistance up, and it only builds up more resistance as the fan speeds up. You know, so if they've got some technology that, well, it just saves power in general, it'll do a lot better for us, you know, off-grid solar users. And if there's one that is basically an evaporative cooling system, it'll be a lot better than a compressor one, because we wouldn't need to go buy massive inverters to be able to handle the start-up surge that you get with electric motors that are starting under load. You may say, how about getting a compressor air conditioner that's 12 volts? I've looked into it. I made a video on it quite a while ago. Try about $5,000 a piece. Forget it, basically. You know, I've seen one of these ones that cost about $3,500 being demonstrated on a boat. It was for a boat system, and it cools itself by pumping water, and it got a lousy... It was so useless, they might as well have been pumping the water out of the lake through a radiator and then back out into the water again, and then just have a fan behind that radiator that recirculates the air through the room. That's how useless this compressor system was. It was a 12-volt system made for marine use. And at $3,500, they can shove that where it fits, basically, if it's that useless. But anyways, I just thought I'd bring that up because you guys might be interested, and it's a possibly good off-grid option that won't allow or require you to buy, you know, giant inverters to be able to run the compressor ran systems that are standard in houses today.